Good evening, sir. Today our group will present about auto-tuning PID controller based on improved genetic algorithm for reverse osmosis plant. First, I will introduce our group members. First, Dalini, Avinash, Hussein, Inisha, and myself, Sharifah Asma. For abstract, the technique for creating proportional integral derivative PID controllers described in this paper is based on genetic algorithm GA. The development of auto-tuning proportional integral derivative PID controllers based on evolutionary algorithm has various drawbacks. The performance of the PID controller has been greatly enhanced by the application of GA to optimize the gain coefficient. Numerical simulations are given to evaluate the purpose method applied to a system with variable parameters.
The
Additionally,
topic we have
the
chosen
brushless
is auto-tuning
servo-motor
PID
can
controller
be
based on improved
controlled using
genetic
this
algorithm for
method.
reverse osmosis plant. So, a little introduction about the topic. What is it? An optimal control of reverse osmosis RO plant is studied in this paper utilizing the auto-tuning concept in conjunction with PID controller. RO is a process used to clean brackish water or to dissolve seawater. The process consists of recovering water from a saline solution pressurized by pumping it into a closed vessel to a point greater than the osmotic pressure of the solution. Thus, the solution is pressed against a membrane so that it is separated from the solutes, the dissolved material. On the sorry. On the other hand, RO desalination plants are energy intensive and require fine-tuned components. Therefore, a good control design is necessary to maintain water production cost at acceptable level and to elevate the plant availability. It must be noticed that a great amount of plants has time varying dynamics due to external or environmental causes, for example, temperatures and pressure. So the main objective of the control system is to maintain a constant pH. Also, it is important to reduce the impurities by checking a conductivity because impurities can be reason of a membrane damage. It helps the efficiency of reverse osmosis process to rise. Also, due to its high potential for global optimization, GA has received great attention in control systems such as the search of optimal PID controller parameters. Although GA has widely been applied to many control systems, its natural genetic operation will still result in enormous computational efforts. This expectation makes necessary for humans to look for new alternative ways for pressuring a dependable supply of drinking water. The significance of this problem is increasing in the underdeveloped countries as well as in industrial. So next about the 10 articles where we have for each article we have to identify the main components, the parameters and the result obtained. Hence, me and my teammates have found the 10 articles. For example, for the first title, it is about the design of tuning mechanism of PID controller for application in three-phase induction motor speed. The controller used is PID controller, and the parameters for this project includes supply frequency, voltage, stator resistance, stator inductance, motor resistance, rotor inductance, magnetizing inductance, inertia, and number of pole. It also has a plan um, of set speed, PID controller, motor and scope, and it has results which stands in times and amplitude. For the second article, it is about the database tuning of PID controller, a combined model reference of VRFT method. It is also a PID. It also uses the controller PID, and its parameter stands of from open loop data, closed loop data, and closed loop data initial turning. For the third article, it is the tuning of the PID controller to minimize IAE, ISE, or ITAE performance indices. It also uses the PID controller where the parameters stands from controller proportional integral derivative. For the third article is entitled PID Controller Optimization by GA and its performance on the electronic hydraulic servo control system. It has its plants which is connected from the input, and then its output is the motor. The parameter tables consist of the closed loop response, rise time, maximum overshoot, settling time, and steady state error. The next article is about the design for auto-tuning PID controller based on genetic algorithm, which uses also PID controller, and the parameter stands from the second order system and the third order system. Next article is the next article is about a multi-population genetic algorithm approach for PID controller auto-tuning. It also uses PID controller, and it has two results, and it also has a parameter table.
Hi, I'm Tishan here. As you can see on the screen, my topic I'm going to present is the state of art, that is evaluation process using fitness function. The objective of this function is the most important stage in using genetic algorithm is to decide which objective function will be used to determine each chromosome fitness. The goal function are performance indices. That objective function are mean of square errors, MAC, integral of time multiplied by absolute error, and integral of absolute magnitude of error, and the last is integral of square error. And the right hand side is the equation for the MAC and IAC. In response to the error situation, the PID control is used to minimize the value of the performance indices indicated above, or to put it another way, to diminish error signals. We define the chromosomal fitness as the smaller the value of the performance index of the linked chromosomes, the more fit chromosome will be equal to the equation with the fitness value equals to 1 over performance index. And the next is these are the schematic of proposed hybrid random generator, and the genetic algorithm should generate a random numbers more purely and for a longer period of time. And the list that below are the steps. The first is to create a random values during a genetic algorithm processing. Use the random generator function. And the second is the Cauchy distribution function approach, which is displayed may be used to obtain a first random number. And third is the mechanism of linear congruent generator is represent. And the last is return the final value to genetic algorithm. And these are the schematic of auto-tuning PID controller based on improved genetic algorithm. NS auto-tuning PID controller for a RO plan that search for the best control gain parameters Kp, Ki, and Kd with the increased GA, that is genetic algorithm. And the proposed optimal PID control search procedures are illustrated as follow. And these are the schematic of the PID control based on improved that is genetic algorithm. And this flowchart shows that the implementation of the new hybrid random of number generation technology and genetic algorithm goal function is the schematic illustrate. And these are the flowchart of the improved genetic algorithm. And hence the genetic algorithm method used in this report is the first is people who are typically chosen at random makeup at the tribes. Initially population individuals in the initial population are usually the ones who are discovered the answer using a technique selected by the issue domain. The starting population of in this work were given random values. However, the values place the restriction on their ranges. Is true that the limitation will be affect the GA research result. Nevertheless, the ranges of PID values were sensibly selected rather than picked at random with the goal of obtaining more reliable, effective, and the precise answer. The second is the RO plan is used in very generation and the PID parameters that characteristic its create a set of mistakes that were used to determine the RMC value from the transit to the steady state from the equation. Each individual in the current population is evaluated using the objective function, and the fourth is that if the determination standard example the generation number is more than the present number is made the best solution, then PID gain parameter is written. And the fifth is the selection of individual. These are the selection of individual from the present population is based on the fitness value that were previously computed. The genetic operators, that is reproduction, crossover, and mutation using a random generator are applied to this individual to create a new population. And the last is a generation, which is what happened when the action is starting in step 2. In step 2, this is a step 2, continue until the termination requirement is met. Thank you.
Next, I will explain about state of art. For the advantage, it is a straightforward algorithm that is simple to comprehend and use. Algorithm robust GA is a nonlinear process that can be successfully used in the majority of industrial processes. For the advantage, frequently used flexible structures that are typically lightweight. Second, have relatively low damping for the basic and initial model. Vibration reduction is a curious problem associated to flexible structures.
Hi, my name is Shavinash Murugan. Today I am going to present methodology in our mini project control principle. Methodology. The PID controller is well known and commonly utilized to increase dynamic responsiveness while also reducing or eliminating steady state error. The derivative controller increases transition responsive by adding a infinity zero to the open loop plan transfer function. In integral control adds a pole at the origin, increasing system type by 1 and lowering steady state error due to a step function to 0. PID controller consists of three types of control: processional, integral, and derived control. Now we going to the controller. The first is proportional control, and this is the schematic diagram, and down is the formula for the controller. To control the system, the proportional controller output employs a proportion of the system error. This, however, causes an offset error in the system. And second is the integral control. This is the formula, and the integral controller output is proportional to the amount of time the system has an error. The integral action eliminates the offset provided by the proportional control, but provides a phase lag to the system. Third is a derived control, and the formula for the derived control is there. The derived controller output is proportional to the error rate of change. Derivative control reduces or eliminates overshoot and introduces a phase lead action that eliminates the phase lag generated by the integral action. Continuous PDI control. These are the formula. The three controller type are combined make a PDI controller with the transfer function. The first is genetic algorithm. Holland introduced the fundamental idea of GA for the first time. This approach was inspired by the mechanism of nature selection, a biological process in which stronger individuals are more likely to success in the competitive environment. GA employs a direct analog of such natural evolution to do global optimization in order to tackle accidentally complicate issues. In binary coding, it is the value of a byte. Real coding alters the overall value of the chromosome. The search space is explored by seeking for better points using the motion operator. The method is a repeat until the population coverage to the global maximum or another stop condition is reached. The second is genetic operator. The genetic operators are applied to selected individuals from the existing population in each generation to establish a new population. The three primary genetic operators of production, crossover, and mutation are used in general. The phase of the covariance can be modified by employing varying probability when using this operator. Crossover and mutation operator must be carefully constructed since their selection
So
has a
now I'd
significant
like to
impact
explain about the
on
results
the
and
overall
discussion.
performance of the
So the
genetic
figure 1
algorithm.
shows the simulating of auto-tuning PID controller based on improved GA. So this system is this circuit is built on MATLAB using Simulink. So the second picture shows the parameter and the value. So for the selection method, the value is rooted wheel. The population size is 80. Generation size is 220. Crossover probability is 65% and the mutation probability is 0.1%. And last one is ranges of PID gain values is -1000 to 1000. So from there we can conclude that the most extensively used RO plan now features a control system that uses empirically derived parameters. So the figure 4 depicts the simulation idea in which the GA and PID controller actions are applied in the MATLAB environment. In general, the figure 1 describes that GA is built on the basis of probability utilizing a random function. Traditionally, GA has made use of the random function in MATLAB or C language libraries. However, more dependable random functions are necessary for improved GA performance. So these are the results that we got in MATLAB. So the figure 1 shows the SAP response and the figure 2 shows the response trends upon improved GA. So we can see the difference between the both results. So from here we can conclude that the numerical simulation is used to validate the efficiency of the suggested strategy. The parameters of the GA in the study are as shown in table 1.
It is clear that an enhanced GA-adjusted PID controller has a quicker settling time. Furthermore, the overshoot is significantly smaller than with the traditional GA turn controller and the Ziegler-Nichols turn controller. So the table 2 compares the performance of the enhanced GA based PID controller, the standard GA based PID controller, and the Ziegler-Nichols approach. So this is the table of performance comparison. So the item is peak amplitude, overshoot, raising time, settling time, final value, P gain, I gain, and finally D gain. So from here we can conclude that the improved GA value is lesser compared to GA and Ziegler-Nichols.
As a conclusion, this study presents the design of an auto-turning PID control utilizing GA. The perimeter convergence in the GA was readily overcome to produce the gain coefficient for the GA PID controller. Simulation findings show that the suggest controller performs better in terms of dynamic and static features than ZNPID. Regarding the modeling techniques, our objective is to take time-variant plans into account. When a robust control response is desired, a large number of control criteria should be desired in terms of optimization, which is the extension for a multi-objective optimization will be natural. Multi-population can be applied in this situation to reconcile the competing goals. Finally, digital hardware such as FPGA would be used to construct the suggest system in real time. That's all from our groups. Thank you.